Hi friends, in this video we'll discuss about Python variables to store values. In my previous videos we understood mathematical operations and built-in functions. We can now move on to a very important concept in programming, and that is variable. So far we worked with all kinds of values such as integer values. This is the value 24,000. Now this is a value. Notice the term that I'm using. You can subtract two values and get a result that is also a value. 24,000 minus 10,000 will give you 14,000. Let's perform another mathematical operation, and that is 14,000 minus 5,000. This gives you the value 9,000. Let's say you wanted to use this computed result 9,000 in another place. You would have to recompute it. 9,000 isn't stored anywhere, and that is where the importance of variable comes in. Variables in programming language are basically just containers which hold values. And these values can be anything: numbers, strings, computed results, and anything. Once a container holds a value, the value that container holds can be updated later on in that program. Because it is a wrapper or holder of a value, that value can be changed. And this is how you would initialize a variable in Python. Here, salary is a variable, and notice how it is made up of alphanumeric characters which are not in quotes. The equal to operator assigns a value to a variable. Here, the value 24,000 is assigned to the container or variable salary. And if you type out salary, the value held in the salary will be printed out to screen, which is 24,000 within a Jupyter notebook cell. So when you type out a variable, the value held within that variable will be printed to screen. Let's give some meaning to the mathematical operation that we performed earlier. The salary is 24,000, the house rent that you pay is 10,000, and your food expenses are 5,000. So house underscore rent is a variable that stores the value 10,000. Food underscore exp is a variable that stores the value 5,000. And if you simply type out house underscore rent within your code, the value held within it will be printed to screen. Let's try the same thing with food underscore exp, and you can see that what is displayed on screen is 5,000. Now that we have values stored within all of these containers, we can do interesting things. The total underscore expense that you incur in the sum of house underscore rent plus food underscore exp. Observe how you sum house underscore rent plus food underscore exp. This will add up the values in those variables, those two variables, and assign the result to the variable total underscore expense. So Python will perform the addition operation on the values within house underscore rent and food underscore exp and store the result in total underscore expense. When we type out total underscore expense, the result will be displayed. As you can see, it's 15,000. What are your savings? You can perform another calculation to get this information. You have your salary, you subtract your total expense from the salary and store the result in the saving variable. Simply type out saving within your cell code to see the value that it holds. You can see the total savings that we have is 9,000. Let's now use the print built-in function that we have seen before in my previous videos, but this time we'll invoke the print function with two arguments. These arguments are separated by a comma. The first argument is a string, which simply says my savings in a year is followed by a colon. This is the string in quotes. The second argument to the built-in function is our variable savings. So the built-in function will take in the value of savings and print out to screen in a concatenated manner. My savings in a year is $9,000. Let's work with some more variables so that we get used to this idea of containers for our values. Course underscore fee is the variable which holds the value $2.99. Num underscore of underscore months is a variable that holds the value 6. Variable name in Python can be made up of uppercase and lowercase letters. So A to Z, all uppercase, A to Z, lowercase, digits 0 to 9, and the character underscore. No other characters are allowed in variable name. In addition, a variable name cannot start with a digit. It has to start with either underscore or a letter. Let's perform a few operations using these variables. The total underscore fee is the course underscore fee for a month multiplied by num underscore of underscore months. So instead of using values directly, you can use the variables and print out the values of the result using the print function. Total underscore fee is the variable on the left side of the assignment operator, which holds the result of this calculation, which is 1794. We'll now create two more variables, num1 and num2, and assign the value 2 to both of these variables. Let's invoke the print function, and this time we want to print out computed result num underscore 1 plus num underscore 2. Python will first calculate the result, which is 4, and print function will print 4 out to screen. The result that we calculated as an input to the print function was not really stored anywhere. If you want to store the result permanently for the duration of your program, you need to store it to a variable such as total here. Now, if you print out the value of total, you can see that it contains 4, the result of num underscore 1 plus num underscore 2. Python supports string concatenation using the plus operator, so you can concatenate two strings, day and light, by simply using the plus operation, and you get the result daylight. But what if you try to perform such an operation on two different type of values? So you have num underscore 1, which is assigned the number 2, and variable num underscore 2, which is assigned the string 2. Remember, anything in quotes is a string, even if it is a numeric value in quotes. Now, if you try to perform the operation num underscore 1 plus num underscore 2, you will find that Python does not understand what it is you want to do. This is an error. It is an unsupported operand. Plus is not supported between an integer value and a string value. How do we know the type are mismatched? Well, you can use the type function like type open parenthesis num underscore 1 close parenthesis is an integer. It is not in quotes. And type open parenthesis num underscore 2 close parenthesis is of type string because this value is in quotes. Now let's see and learn how we can work with different type of variables in Python. We have worked with integers, floating points, numbers, and strings. What we haven't yet seen are Boolean values. Boolean values refer to true and false are both keywords in Python. Here, the variable x holds the Boolean value true, and the variable y holds the Boolean value false. You can see that true and false are highlighted in green, indicating they are keywords that Python understands. I will now invoke the print function here, which will introduce a number of new concepts. Once again, we have passed in two arguments to the print function. One is a string which says x and y is, followed by a comma, and then we have an operand x and y. This is a logical operation. If you remember, logical operation from back in school, x and y will be true only if both x and y are true. X is true, y is false, the result of x and y will be false. And this is what you see here in the result, x and y is false. Python also supports logical operators such as OR. So we want to print the result of x or y will be true if either x or y is true. So the result there is true. For the logical operator, only one of the two values needs to be true. Here x is true, which is why the result is true. Python also supports the negation or the not logical operator. We know that the value of x is true, so the not or negation of x is false, and that is why you see here in the result. Let's do the same thing for y as well. We'll print out the not or negation of y. Y is false, so the negation of not of y is true. Let's go back and work some more with the string variables. Let's assign a new variable x with the value awesome, which is a string. The variable x here simply contains awesome. Remember, you cannot concatenate strings using the plus operation. We have two strings here. Python is in double quotes, that is simply a value. And we have the string in the variable x, so x plus Python will concatenate the two strings together. We get the result, Python is awesome. String concatenation is possible using the plus operator on two variables. We have initialized two strings here, x and y. X contains the value Python is, and y contains the value awesome. Observe here that the variable x in a variable that we have used before, it earlier contains the value awesome. This time, we updated the value contained within the variable to be Python is. The whole idea of having a variable is that you can change the value that it holds based on your need. Now, we are calculating x plus y and assign the result to the variable z. And we are going to print out the value of z, which is simply Python is awesome. If you remember from an earlier demo, you can multiply a string with an integer. So you have the string z, which contains the value Python is awesome. You can multiply it by 4 and store the result in a. A here is simply a string with the value Python is awesome. Repeated 4 times thanks to our multiplication. Let's invoke the len built-in function on the variable x. The last assignment variable x was a string containing the value Python in, followed by a space. So the total length of the string is 10. Observe how you can pass in variable as input argument to any built-in function. The function will simply take the value within that variable and perform its action and calculation on that value. Len of z will compute the length of the string stored in z, which is Python is awesome, with the length of 18. So now let's see and learn how to assign values to variables in Python. When you work with Python, you will see that there are many different ways to assign values to variables. Observe the first line on screen here. x equals to y equals to z equals to Python in double quotes. Such a statement will be evaluated from right to left. So the rightmost value here, Python, will be assigned to the variable z. The value in the variable z will be assigned to y. The value in variable y will be assigned to x. Then finally, if you print out the value of x, y, z, you will find that all of them have the string Python. This is a shortcut that you can use to assign multiple variables to the same value. We have already seen that you can concatenate strings using the plus arithmetic operator, that is b equals to x plus y. So b is equal to Python, since x and y both contains the string Python. I will now introduce a new category of operators in Python, comparison operators. Comparison operators can be used to compare two values. So result of comparison is always a Boolean, say true or false. And the double equals to sign is the equality comparison operator. Then you have the less than operator, greater than operator, less than equal to, greater than equal to. Let's take a look at the rather confusing assignment here in Python, which uses the equality comparison operator. Remember that when you see assignment like this, evaluate this from the right to left. Observe the double equals to sign between y and z. This means that y is being checked to see whether it's equal to z. If the value in y and z are exactly the same, the result will be true, and true will be assigned to x. If they are different, the result will be false, and false will be assigned to x. Y is exactly equal to z, which is why x is true. Python has first compared the value of y with the value of z. Both contain the string Python. They are exactly the same. And the Boolean result, which is true, y is indeed equal to z, is assigned to the variable x. Let's study variable assignment in a little more detail. Here we have two variables, color underscore a and color underscore b, assigned to red and blue respectively. And we print out the value of these variables. So red blue is printed out to screen. In Python, it is possible to assign a value to a variable using the value in another variable. For example, color underscore c equals to color underscore a will take the value held in color underscore a and assign it to the color underscore c variable. And if you print out these values, you will see that color underscore c contains the value red, the same as in color underscore a. It is important here to know that color underscore c and color underscore a are both different containers containing the same value red. Let's see what the implication of that are. Let's say you assign color underscore a to color underscore b, and color underscore a was initially red, so color underscore b was blue, and now we get the result. Color underscore a is now blue, but color underscore c contains or continues to be red. Updating the values within the color underscore a container did not affect the color underscore c container. Color underscore c contains the value red as it did before. Now let's see how we can update variable values in Python. So in this demo, we will further deepen our understanding of how variables act as container and how we can change the values that live within these containers and the implication of this change. So I'm first going to declare three numeric values or variables, n1, n2, and n3, and they contain either integers or floating point numbers. Floating point is any number with decimal or fraction. I am then going to move on and create two string variables, s1 and s2, the first of which contains the string hello and the second contains world. The variable that we have created hold the value that we have assigned to those variables, and we can then use them in calculations. This is something that you are familiar with. Total underscore n equals to n1 plus n2 plus n3. We'll sum up the values in those variables and assign the result to a new variable total underscore n. And if you look at what total underscore n contains, it is 168.5, the sum of three numeric values that we had set up earlier. Now, the whole idea of the term variable is that value that it holds can change. So you can reassign a value that is held within a variable. For example, when you say n1 equals to n1 plus 1, Python will first evaluate the result n1 plus 1. We know that n1 currently contains the value 34. It will add 1 to 34, get 35, and store this result in n1 itself. So if you print out the value of n1, you'll see that n1 now contains 35. It is no longer contains value 34. And such operation using variables in Python are extremely common. n2 equals to n2 plus 10 will take the existing value of n2 and add 10 to that and then store the result in n2. So it will take 34.5 plus 10 equals to 44.5, and as we can see, n2 now holds the value 44.5. And really, these operations are what make the variable get its name. So you can vary the variable that are held within variables. You can update these values. n3 minus 50, n3 was initially 100. You subtract 50, you get 50. n3 now holds the value 50. Now, what if you perform another operation with n3? Say n3 equals to n3 multiplied by 50. In this computation, Python will use the last value of n3 that was stored within the variable. The last value stored was 50, so we get 50 multiplied by 50. The result 2500 is what is now will be stored in n3. And if you take a look at n3, you can see that it's 2500. Let's say now we perform one more computation within n3. n3 divided by 50, the last stored value in n3 was 2500. 2500 divided by 50 gives us 50. n3 once again contains the value 50. So let's now take a look at some other interesting syntax that Python supports. Let's see if you can figure out what Python will assign to n1 in this situation. The current value is stored in n1. Variable is 35. We have initialized it to 34 and then incremented it by 1. So Python will first evaluate the expression on the right hand side of the assignment operator, that is n1 plus 1, and it will get 36. What you might have observed is that the plus equal to operator is not a simple assignment, and the fact is it means addition plus assignment. It means add what is on the right hand side, that is 36, to the current value of n1, which so far is still 35. So it adds 36 to 35. The result is stored in n1. That is what the equal to refers to in the plus equals to operator. So the result is n1 equals to 71. Evaluate the right hand side, get the result, and add the result of the right hand side to the value in the left hand side, and store the result in the left hand side once again. Let's see a slightly simpler variation of the addition plus assignment to drive the point home. n2 plus equals to 10. The current value of n2 equals to 44.5, and on the right hand side we only have 10. So we take 10, add that to the current value of n2 and store the result in n2. So 10 plus 44.5 equals to 54.5. n2 now has the value 54.5 stored within it. The use of arithmetic operation is combination with the assignment operator extend to other arithmetic operators as well, such as multiplication or division. n3 multiplied by equals to 50 takes the current value of n3, multiplies it by 50 and stores the result in n3. So n3 is now 2500. The value stored in n3 is now 50. Let's try division equal to operator. It takes the current value of n3. The last stored value is n3 is 2500. So 2500 divided by 50 stored the result in n3, and n3 is now equal to 50 once again. The combination of arithmetic operator with an assignment operator is often used as a shortcut in Python, and this is something you should be familiar with. We have seen that the arithmetic operator plus can be used with a string as well. Here s1 plus s2 will combine hello plus world, and the result is concatenated string hello world that is stored in the concat underscore string variable. We'll now perform a computation that changes the value that is stored in s1. s1 equals to s1 plus yoo. s1 was initially hello. We concatenate yoo to get hello yoo. This is what is now stored in the s1 variable. Let's perform a simpler computation with s2. s2 equals to s2 plus yippee. s2 was initially world. We concatenate yippee to the end of s2, and s2 is now currently world yippee. Well, now assign the current value of s1 to variable called new underscore s1. This is an entirely new container, an entirely new variable. So new underscore s1 contains the current value of s1, which is hello yoo. Now you have assigned new s1 to the original value of s1, and let's say you change the value that is stored in the s1 variable. You set it to some other string. Now s1 is equal to some other value. Now when you take a look at the content of new underscore s1, you want to see what value held within it. You will find that it remains unchanged. It continues to be hello yoo. This is the value that we had assigned to new underscore s1. So even if we had changed s1, the variable that was created using the last value of s1 continues to hold this last value hello yoo. In order to understand this point more clearly, let's see this with another variable, the numeric variable n3. We assign the current value of n3 to a new variable, sum underscore n. So sum underscore n currently has the value 50. We'll now perform an arithmetic computation which changes the value held in n3. We multiply n3 by 1000 and store the result in n3. So n3 has a value of 50,000. Now sum underscore n, which was assigned the value of n3 earlier, continues to have the values 50 because that was the value of n3 at that time of assignment. So even though we have changed the value of n3, sum underscore n continues to be 50. This is important for you to remember. Once we have created a new container, it contains to hold the value it was assigned until you explicitly change the particular variable or that particular container. So friends, to conclude, we just understand the variables, which are fundamental building block in Python, or in fact in an programming language. Instead of using value directly, you can have meaningful variables which represents what the value is. So for this video, we will keep up to this, and in our next video, we will cover up some new concept of Python and improve our expertise on this language. Till then, thank you and bye-bye.